In this video, we will be learning about the working of IC555 as an astable multivibrator. This is the diagram of an astable multivibrator using IC555. The circuit consists of IC555, resistors R1 and R2, capacitor C. This is the expanded diagram of 555 as an astable multivibrator. Astable multivibrator using IC555 consists of IC555, resistors R1, R2 and C as shown in the diagram. Some notations used in this presentation. Transistor TR is colored red when it is off and it is colored green when it is on. The comparators A1 and A2 are colored red when its output is low and green when its output is high. The output waveform of the astable multivibrator is presented as a sequence of phases from the moment when power supply is switched on. Initially, let us consider the condition if 555 is in reset state. If pin number 4 is connected to ground, 555 is in reset state and pin number 4 of 555 is internally connected to the reset input of the SR flip-flop. We know that when SR flip-flop is in the reset condition, irrespective of the values of S and R, output Q is low or 0 and Q bar is high or 1. As Q bar is high, transistor TR's base emitter junction is forward biased, so transistor TR is in the on condition. As transistor TR is on, pin number 7 is connected to ground through the on transistor TR. So capacitance will not charge, it will be in the discharged condition. Case 1. Initially, voltage across the capacitance is equal to 0 at power on. Voltage at the inverting input of op-amp A1 is equal to 2 VCC by 3 and voltage at the non-inverting input of op-amp A1 is equal to 0. So, differential input voltage is negative. So, output of op-amp A1 is low. For the SR flip-flop, R input is equal to 0. Voltage at the non-inverting input of op-amp A2 is VCC by 3 and voltage at the inverting input of op-amp A2 is equal to 0 as capacitance is in the discharge condition. So, for op-amp A2, differential input voltage VID is positive, so output of op-amp A2 is high. For the SR flip-flop, S input is high. As S input is high and R input is low, for the SR flip-flop, Q is high or logic 1 and Q bar is low or logic 0. As Q bar is low, transistor TR's base emitter junction is not in the forward biased condition. Transistor TR is in the off condition. Capacitor starts to charge through resistance R1 and R2. Whenever capacitor voltage exceeds VCC by 3. So, voltage at the non-inverting input of op-amp A1 is less than 2 VCC by 3 and voltage at the inverting input of op-amp A1 is equal to 2 VCC by 3. Differential input voltage is negative, so output of op-amp A1 is low. For the second operational amplifier, voltage at the non-inverting input is equal to VCC by 3 and voltage at the inverting input is a value greater than VCC by 3. Differential input voltage is negative, so output of op-amp A2 is also low. For the SR flip-flop, both the inputs S and R are existing at logic 0. So output of the SR flip-flop is equal to previous output. SR flip-flop retains its previous output. Q is equal to 1 or high and Q bar is equal to low or 0. As Q bar is low, transistor TR space emitter junction is not forward biased. So transistor TR continues to be in the off condition. So capacitor C continues to charge through resistance R1 and R2. Whenever capacitance voltage becomes slightly greater than 2 VCC by 3, for operational amplifier A1, the voltage at the non-inverting input becomes slightly more than 2 VCC by 3 and voltage at the inverting input is equal to 2 VCC by 3. Differential input voltage VID is positive. So output of op-amp A1 becomes high. For the SR flip-flop, R input is high. For op-amp A2, voltage at the non-inverting input is equal to VCC by 3 and voltage at the inverting input is a value which is slightly greater than 2 VCC by 3. So differential input voltage is negative. So output of op-amp A2 is low. So for the SR flip-flop, S input is equal to 0 and R input is equal to 1. SR flip-flop is in the reset condition. That means Q is equal to 0 or low and Q bar is equal to logic 1 or high. As Q bar is high, transistor TR space emitter junction is forward biased. So transistor TR is in the on condition. So capacitor starts to discharge through resistance R2. So capacitance starts to discharge and voltage across the capacitance is between VCC by 3 and 2 VCC by 3. Capacitor voltage is greater than VCC by 3 but less than 2 VCC by 3. For operational amplifier A1, voltage at the non-inverting input is a value which is less than 2 VCC by 3 and voltage at the inverting input is a value which is equal to 2 VCC by 3. Differential input voltage is negative. So output of op-amp A1 is low. For op-amp A2, voltage at the non-inverting input is equal to VCC by 3. Voltage at the inverting input is a value which is greater than VCC by 3. So for op-amp A2, differential input voltage is negative. So output of op-amp A2 is also low. For the SR flip-flop, S input is equal to 0 and R input is equal to 0. Output of SR flip-flop is equal to previous output. SR flip-flop retains its previous output. So Q is equal to logic 0 or low and Q bar is equal to logic 1 or high. As Q bar is high, transistor TR space emitter junction continues to be in the forward biased condition. So transistor TR continues to be in the on condition. So capacitor C continues to discharge through resistance R2 and on transistor TR. So capacitor continues to discharge. Whenever capacitance voltage becomes slightly less than VCC by 3, voltage at the non-inverting input of op-amp A1 is a value which is less than VCC by 3 and voltage at the inverting input is a value which is equal to 2 VCC by 3. Differential input voltage is negative. Output of op-amp A1 is low. For op-amp A2, voltage at the non-inverting input is equal to VCC by 3 and voltage at the inverting input is a value which is slightly less than VCC by 3. For op-amp A2, VID is positive. As VID is positive, output of op-amp A2 is high. As output of op-amp A2 is high, for the SR flip-flop, S input is 1 and R input is equal to 0. SR flip-flop is in the set condition Q is equal to 1 or high and Q bar is equal to low or 0. As Q bar is equal to 0, transistor TR's base emitter junction is no longer forward biased. Transistor TR is turned off, so capacitor starts to charge through resistance R1 and R2. So the sequence of operations continues. Again case 2, case 3, case 4, case 5 and so on. This is the output waveform of 555 as an Astable Multivibrator. Thanks for watching Circuits Analytica. Enjoy learning.